All right, guys, so today we're going to be looking at operations with polynomials. A polynomial is the sum or difference of many monomials. So monomials can be a single number by itself. It can be a number with an x or any degree of x. And a polynomial is a combination of them. So we can have them added, subtracted together. So this would be a polynomial with three terms in it.
Wait, is that standard form?
This would also be in standard form. So the highest degree of a polynomial is called, or the highest exponent is called the degree. So in this case, if we're going to talk about this one, the degree of this polynomial is 2. It is our highest exponent. Standard form is starting with your highest degree and working your way down. So highest degree to lowest, or 0 degree. Okay, so an example of that could be this, right? X squared plus 2x minus 3. Whatever your highest degree is, you want to start there and work your way down to where you no longer have that degree or that variable. So write the following polynomials in standard form. So whenever we do problems like this, what we want to do is we want to start with the highest degree. So if we're looking at number 10,
It'd be negative 3k.
we want to look for our highest degree,
Oh, k5.
k to the fifth. So we have negative k to the fifth, negative k5, minus our 3k cubed. And we go to our next
plus
highest.
1/4 k squared.
Plus 1/4 k squared plus 8k and minus 1. Okay, so there's our standard form. Highest degree, working our way down to our lowest degree. In cases where we have multiple variables, again, we still want to start with the highest degree.
So it'd be 4a cubed.
Okay, so we want to start off with the highest degree. So I have a squared, b squared, a cubed. So we want to start off with that a cubed. I always mark them out just to make sure I know I've used them. Then go to your next highest degree of a.
Could it be 18a squared b squared?
Yes. Perfect. So 18a squared, b squared.
And then minus b squared, right?
We want to go to our next highest a degree. So this is where it gets
Oh, A.
confusing. So we want to keep that a degree in that descending order. We went 3, 2, 1, and then now none in that order. Okay. So whenever we have those two variables, it does get a little bit more confusing. Again, just start with your highest variable's degree and work your way down from there. Okay. Mm-hmm.
What if there's a higher b, like, because if there's 18a squared b squared, if there's like b to the third?
There's b to the third, then we could start with either a or b, and then continue that track down. Okay.
Wait, I'm lost.
So if he said there was a b cubed,
Or just like a higher, like,
or a higher,
exponent.
if they were the same value, like say this is a cubed and we had a b cubed, we could keep this same order and just have a b cubed at the end because we're descending from that highest a down. Or we could do.
You wouldn't put a cubed and b cubed together. They'd have to be like.
They'd have to be separate.
It's like you have to like separate the letters out. It's like a cubed.
As long as they're not part of the same term. So like 18a squared b squared, we have another b squared, but it doesn't have that a squared with it. Okay.
Okay.
So it has to match exactly.
It's got to match exactly in order for them to be like terms.
Do you have a question?
So let's look at number 12. Because this one we can kind of have different orders and it still be in standard form.
Would it be y4 first?
Y to the fourth is going to go first because it's the highest degree.
And then I don't know if it's 9 or 5.
It would
We're
probably
going
be
to go with the 5 because that's our next descending order of y. So that's a y squared.
Oh, and then the 9,
and then the 9,
and then the negative x squared, and then the 2.
and the negative x squared, and our last is without variables, that plus 2. Okay. So it can be a little bit confusing. Of course, we could have also possibly started with our x squared, and then we could have gone 9xy, 5xy squared, plus 2, plus 5 to the fourth. Again, this would make the most logical sense. Start with the highest degree, work your way down.
Yes, sir.
So then the next thing we want to look at is how we can actually classify polynomials. So we've got two different ways of doing it. The first is by our degrees. And so our degrees going down, we have a 0 degree. And so an example of that would be any number. So any number, so 1, -1, 3, those are all one number. They never change. And because they never change, we call those a constant. Okay. So it doesn't matter, 1 is always going to be 1. 3 is always going to be 3. But as soon as we give a degree or a value with an x, these values are no longer constant, right? They're going to change based on what that variable is. So in this case, we can have an x, we can have a 3x, or a 1x, or negative 1x. These terms are called linear. Our next degree going up, we're adding a power to our x, so we have x squared. Again, we can do like 3x squared or any other coefficient on that x squared. These are our quadratics. Our third degree, x cubed. This is our cubic function. Our fourth degree,
x4,
x to the fourth.
and what's it called?
This is a quartic function, a quarter, quartic. And then our last one, our fifth degree, so x to the fifth power. This is quintic. Okay.
Weird name.
Weird names, right? All based on, I think they're Latin.
Wait, so is our answers going to be words?
Sometimes, yes. So if it asks for the name or the classifying of the polynomial, it will be words. So the next way we can classify is by the number of terms. Again, the number of terms is based off of how many pieces or terms are added or subtracted. So if we have a single term, or 1, we call those monomials. If we have 2, we call those binomials. So think humans were bipedal, we have 2 legs. Bi meaning 2. 3. Anybody want to take a guess? Trinomials. Think tricycle, we have 3 wheels. Tri, 3. And 4, this is our catch-all for anything bigger. We just call them polynomials. Poly meaning many. Okay. So there's our number of terms. Monomial, 1, 2, 3, and then poly just meaning many.
So these are going to be over here, like this little worksheet that we're on the side,
Yes.
will be words, right?
So we're going to write our
Classify.
words. We're going to classify each of these polynomials by the highest degree and the number of terms. And we can use these charts to kind of answer it out. So number 13.
Would it be like monomial degree or whatever?
So first we want to start with our degree. So what degree is number 13? We have negative 3x plus 1.
It'd be linear.
It's linear because it's got that x, that 1 degree. And then how many terms do we have?
Mono.
So it would be constant binomial.
We got two
two terms, right?
Yeah.
We have addition between two different things. So this is a linear binomial.
That's so weird.
Number 14, we've got 9x to the fifth minus x to the fourth plus 2x. Quintic, it's that fifth degree,
Oh wait, we
And-
don't do the other exponent, it's just the first one?
just the first one. And trinomial. Right? The highest degree is kind of what sets the tone for the entire polynomial. Number 15 is just the number 24,
That's a constant.
so it is a constant.
Look at us go.
Now we can put monomial, but anytime you have a constant, it's always going to be a monomial. Okay, so that's kind of in parentheses.
The next one is gonna be cubic polynomial, whatever it is, so that's how you pronounce it.
Number 16, we got 1/2 x cubed is our biggest. So yes, it's a cubic. And we've got 4 terms, polynomial. 17,
It'll be cubic, not tricycle,
Quadratic.
quadratic.
Quadratic. So we have an x squared, so it's a quadratic.
I literally
So we
wrote
do
tricycle on my
have
paper. You said
3
it and I wrote it down.
terms.
No, Katie, you said it. You really just had me write tricycle on my paper.
I did not make you write that. And then our next one, number 18, we got x to the fourth, which is our quartic. And it's just the x to the fourth, so it is a monomial. So number 19, it tells us, give an example of a cubic binomial. So how could we write a cubic binomial?
Would you explain like
X to the third plus 6.
X to the third plus 6. So anything to the third power plus or minus some other number. Right? To have a binomial, anything to that third degree plus or minus some other term that's not bigger than that degree of 3. Right? You could have an x squared, you could have an x, or you could have a constant term like that 6. Number 20,
3x.
it's an example of a linear monomial. 3x is a perfect example. On to the next page. So now we're going to look at adding and subtracting polynomials. So to add or subtract, what we do is we just combine our like terms when we're adding. So anything is a like term that has the same degree and the same variables attached. Or it's just a number or a constant. So let's look at number 1. And we also want to write it in standard form, so highest degree to the lowest degree. So number 1, we've got 3x squared plus 11x plus 4 plus negative 5x plus x squared minus 13. So starting with the highest degree, we want to combine these. Whenever we have addition, you can kind of just ignore those parentheses. Because again, you can add or subtract in any order. We really just have all this. So we want to start with the highest degree, 3x squared and x squared. Add those together. Our variables don't change when you add or subtract, but the coefficients do. So we're adding 3 to a 1. You're going to say 4x squared. And I like to mark them out just to show that I've used them, right? When you've got all these terms, marking them out is going to make it a little bit easier to keep track. Then we have 11x minus a 5x gives us a 6x. Mark them out. And then we have a 4 minus a 13.
Negative 9.
Negative 9. And we're done. Okay. by starting with the highest degree and working your way down, it puts it in that standard form for us. And we just combine those like terms as we go. When we do subtraction, so if we look at number 3, we got 5k cubed minus 2k squared plus 2k minus 2k squared plus 2k plus 7. What we want to do in this case is, because we're subtracting this entire polynomial, we want to change it to an addition problem. We can distribute that negative to everything on the inside of those parentheses. So I'm going to change it to an addition problem by just changing the signs of everything involved. And then it works the exact same way as adding.
Oh, wow.
Okay? So then start with the highest degree, 5k cubed.
But there's no k cubed on the other side, so you just write it down.
So we just bring it down. Then go to your next highest term. So we have a negative k squared minus, or negative 2k squared minus a 2k squared. Negative 4k squared. Mark them out.
And then it'll be 2k, they cancel out.
So 2k minus 2k, those cancel out.
So it'll just be plus 17.
And then we have that plus 17 left over.
That's it.
That's it. So that's our adding and subtracting, right? Adding, you just keep the terms. Don't change anything. Combine your like terms. Put it in standard form.
Minus 17?
It is a minus 17. Thanks, sir. And then subtracting, change your signs. Combine your like terms. Go in descending order, right? Any questions on adding or subtracting?
So how would we do problems like number 2?
So number 2.
I bet I got it.
So we got 9n cubed. Plus.
Plus 7.
Okay, so again, this is an addition problem. So we're not going to change the signs of anything. We're just going to combine our like terms. So start with the highest degree. In this case, we have that n cubed. So start off 9n cubed. Mark it out. Go to your next degree. So we have a negative 4n squared, a negative 2n squared. This is negative 6n squared. Go to your next degree. 2n plus n. 3n. And then our last, negative 10 plus 3.
Minus 3.
This is a minus 3. Negative 10 plus 7, yeah. I said the answer. Yes.
On number 4, if you turn it to plus between the parentheses, would you change negative 5y and negative y to plus, or keep that negative?
Plus 5y. Yeah. Because you're subtracting, you want to distribute that negative to everything.
Oh,
So everything in that second set changes signs.
So on number 4, since the middle sign is subtraction, we would just be doing subtraction.
Yes. So yeah, number 4, change the signs of everything in this polynomial. So it's a negative 1 minus a 2y squared plus 5y plus y cubed.
So whatever the middle sign is, you flip it to you do the opposite.
If
No.
it's negative.
If it's
If
subtraction.
it's a positive, you just keep it the same.
Right.
Yep.
Do you want us to do 5?
We can do 5 if you want.
Yeah, that worked.
So number 5 says subtract negative 10 ab plus 7a squared minus b squared from 8b squared plus ab minus 2a squared.
Going to be 8b squared minus 8b plus 2a squared.
So yeah, we're going to take ab squared plus ab minus 2a squared. And we're subtracting from that the negative 10ab
Yes.
plus 7a squared minus b squared. So again, we have that subtraction. So we want to go through, change our signs. So this becomes a plus, this becomes a minus, this becomes a plus. And so then we combine our like terms. So start with the highest degree. I'm just going to start with this order. All right, we have that b squared. 8b squared plus b squared gives us 9b squared. Go to your next highest b value. So we have an ab plus a 10ab plus 11ab.
What?
And then we have negative 2a squared minus 7a squared. Both negative, so negative 9a squared. Okay. So that's our addition and subtraction. The next thing is we're going to be multiplying. So when we multiply polynomials, we can, one, distribute if we have two binomials, or FOIL it out. Second thing, combine like terms, so that's just our adding, and then write the answer in standard form. So let's look at number 6 here.
Are we not doing 4?
We can if you want to. Okay. So number 6, one way that we can multiply polynomials is just take each individual term and multiply it out. So you're kind of distributing each term. I like to do what we call the box method and just make a box. So I'm going to take my two values. I have w minus 7 is my first term. And I have w squared plus 2w plus 1. I can drop those positive signs. I just really
I'm
need
so lost.
the negatives.
Where the one? Oh, never mind. Swap. Never mind.
Now I'm going to turn it into a box.
Never mind.
To get inside the box is where we multiply. So we're going to take all of our terms and multiply them in. So we have w times w squared. When you multiply exponents, we add them. Okay, so when we have multiples variables, we add our exponents. So we have a w to the first power times w squared. So we add those two exponents, we get w to the third power. Our coefficients would also multiply. In this case, we have a 1 on our w. So 1 times 2 gets us 2. The w times w is going to get us w squared. 1 times w is just w. Then you go to your next row. So negative 7 times w squared. Negative 7 times 2 gets us a negative 14 w. And negative 7 times 1 is just negative 7. Now the reason why I put it in the box is, one, it just keeps everything nice and neat, but also it groups our like terms on a diagonal if everything was going in a descending order. So here's our like terms kind of grouped together.
That's crazy.
So to get outside the box, we combine our like terms and just write it below. Our highest degree should be in the top left corner if we went in descending order. So we have w cubed. We have a negative 7w squared plus a 2w squared. So say 5w squared. Negative 14w plus a w, negative 13w, and then we have that minus 7. So there's our multiplication, right? We multiplied it all, combined our like terms, and it put it all in standard form kind of by using that box. So it just keeps things nice and neat. It makes it a little bit easier for us. That was number 6.
Yeah.
Let's look at number 7. So this time we have 2x plus 1.
And 4 minus 9x, and then minus 2x, and parentheses 3x plus 11.
So this time we have this subtraction kind of happening in between. So we had these two are being multiplied together, and this term times these two are being multiplied together. So anytime we have a binomial, we have to FOIL it out. We could do the box if we want to. I usually just do it if I have 3 or more terms. If I just have two binomials, I'm just going to FOIL it out. So we have a 2x times 4 gives us 8x, and then we have 2x times negative 9x gives us negative 18x squared. So that was our first, and then our outer, and we have our inner terms. So 1 times 4 gives us 4. And then our last, so 1 times negative 9x.
And then you do minus 2x.
Now we're also multiplying this term by this. So remember, PEMDAS, we need to do our multiplication before we do that subtraction at the end. So we're going to go ahead and distribute this as well. So negative 2x times 3x
Negative 6x squared minus 22.
minus 22x. Okay. Now we can combine all of our like terms. So start with the highest degree and work our way down.
X squared.
So we have x squared as our highest. So we have a negative 18 and a negative 6x squared. So I guess it's negative 24x squared. Mark them out. Then your next term.
X.
We got x. So we've got an 8x minus 9x. Gets us a negative 1x. Minus 22x gets us a negative 23x. And then our last term, we have that 4. And then we're done.
Minus 23x.
Guys, the biggest problem I run into when people are multiplying, adding, subtracting polynomials is you've got to pay attention to what your sign is telling you happening, right? We're taking this, multiplying these two together, subtracting these two. By distributing that negative with it, we're changing those signs and making it to where we can just combine those terms afterward. You guys want to work more of those? Number 9. So number 9 is 2c plus 5d cubed. If something is cubed, that just means we're taking it and multiplying it by itself 3 times. So we have 2c plus 5d times 2c plus 5d times 2c plus 5d. We can erase that cube. So in this case, what we're going to have to do is we're going to take 2 of our terms, multiply them together, combine those, and then multiply by our last term. Right? We can't multiply 3 things together all at once. We can only multiply 2 things together and then take that end result and multiply by that third.
4c squared plus 25d squared.
4c squared.
Plus 25d squared.
We're leaving out some middle parts. So we also have to do that 2c times 5d, which is going to give us a 10cd.
Oh, you're foiling it?
We gotta foil it. Plus another 10cd, then that 25d squared. Now these 2 terms are like terms in the middle when anytime you FOIL. So 10cd plus 10cd is going to give us a 20cd. We have a 4c squared and a 25.
But wouldn't that be cd squared?
Because we were adding them. We multiplied.
Okay.
And so I have a 3 term, and I'm going to multiply by our 2 terms. So I'm going to go ahead and do our little box. Make it easier. So to multiply, get back in. So 2c times 4c squared, 8c cubed. 2c times 20cd is going to get us 40c squared d. And we have 2c times 25d squared is going to get us 50cd squared. Then we have our next term. So 5d times 4c squared is 20c squared d. And we're going to get 100cd squared. And then 5 times 25 is 125d cubed.
And then you gotta find like your like term.
Then we got to find our like terms.
And a diagonal.
And so we do have this diagonal and this diagonal.
So it'd be 8c squared
So we have 8c squared, or
plus
cubed, that's a cube.
cube, sorry. Plus,
And then plus
let's see, I had
60 c squared d plus 150 cd squared plus 125 d cubed.
and that's right.
And that's our answer. So again, that's standard form, right? C cubed, C squared, C, and then no C. So we have it in that descending order. Any questions on multiplying?
Is that all we're doing for today?
Almost.
Yeah.
I thought that was.
You guys want to do the word problem?
Oh,
Word
you have a word problem?
Is it, if it's not gonna be on the test.
We did tomorrow.
Nope.
Yeah.
It's like, oh,
Not coming in on Saturday to do math problems. So let's look at number 12. The height of a trapezoid can be expressed by 2x plus 9. The bases can be expressed as 3x minus 7 and x plus 5. Write an expression to represent the area of the trapezoid. So
Don't ask me, I don't know this stuff. I suck at word problems.
the height of a trapezoid, how do we find, or let's draw our trapezoid real quick. Well, the bases, that's not trapezoid. There we go. Here's our trapezoid. So the height can be 2x plus 9. And then the bases can be 3x minus 7 and x plus 5. So then write an equation to represent the area of the trapezoid. I haven't done geometry in a while. So we can get the area of the inside part by doing x plus 5 times the 2x plus 9. And then we can find the area of the triangle parts by taking, now we're just writing an equation, we're not going to solve it. Just so you know. So we know this length, or this portion, is x plus 5. So we can take our 3x minus 7, and we can subtract from it the x plus 5. And that's going to get us these extra lengths on the side. And then we can take those lengths, because they stack one on top of another, to give us another rectangle. We can take that value and multiply it by our height, that 2x plus 9. And we can add those two things together to give us our total area.
Is there ever gonna be questions like this on homework?
Probably not, I don't know. But that could be our way of solving the area of our trapezoid.
You did put questions like this on homework. You put two
So
in
it
the
must not be on the test.
you should just say 1 through 12.
I don't think it's that hard. All right, so then let's look at the last thing that we're doing today.
Can we do 13 and 14 on homework?
Maybe. Let's get through this part real quick. So we've looked at adding, subtracting, and multiplying. The last part is dividing. So to divide by a monomial, what we're going to do is essentially distribute that value to each. So if we look at number 13, we've got 9m cubed minus 24m squared. And we're dividing this by 3m. Now, whenever you divide by a single term, what we can essentially do is distribute it to each piece and divide by that individually. So I can split it. And the way we do the division, of course, treat the numbers just like any other fraction, reduce it or completely eliminate it. 9 divided by 3 gives you a 3. When we have a variable divided by another variable, you subtract the exponents. So when we multiplied, we added the exponents. When you divide, you subtract. So that's going to leave us with an m squared. And that's our first division. Then we go to our second piece, minus 24 divided by 3 gives me an 8. M squared divided by m leaves me with an 8m. Okay? So our division's not...
Wait, that's it?
That's it. It's not hard. So that's why it's all lumped together, guys. It's the operations.
What about 15?
So let's look at 15. So we've got 14a to the fourth b cubed minus 20a
Squared b squared plus 2ab, close parentheses. Is that times?
It says times.
And then 2ab in parentheses, and then negative 1 is the exponent.
So negative 1 is the exponent. So anytime we have a negative exponent, all that's really telling us is we're going to take this entire thing and move it to the denominator. So if
you're
we're
dividing it.
multiplying, we're dividing it. So again, we can just distribute. We're going to divide each of these by 2ab.
So it'll be 7, 18.
So 14 divided by 2 gives you 7. A to the fourth divided by a is a cubed. B cubed divided by b gives you b squared. Minus 22 gives you 10, gives you an a and a b. Plus, if you have any number divided by itself, cancels out and you're left with 1.
What, 1?
Right? 4 divided by 4 gives you 1. Same as 2ab divided by 2ab gives you 1. Now, one thing that's different with our division, just like if you had a fraction, let's look at number 17.
Where does that negative 1 go?
The negative 1 just means this moves to the denominator.
So you really divided it by
So we're really multiplying by, or dividing by that 2ab. So number 17, we got 30x
x squared cubed
cubed
minus 12x squared plus 9x over 3x squared.
all over 3x squared. So again, I'm just going to go ahead and distribute that 3x squared to each. Kind of separate it out. So 30 divided by 3 gets you that 10. X cubed is bigger than x squared, so we're going to have 10x. Minus 12 divided by 3 leaves you with a 4. My x squareds cancel each other out. They're gone. But on our last one, x squared is bigger than x. So again, we can kind of think about it. If we have 4 divided by 12,
Wait, that's not 3.
it gives us 1/3. Same idea is going to happen with a variable, right? Our bigger value or our bigger variable is going to stay in the denominator. So in this case, we have 9 divided by 3. Our 3 stays on top. But our x divided by x squared, our x squared is bigger. And we'll subtract that smaller number, that 1, from it. So we're going to have an x in the denominator. Okay.
That makes sense.
Does that make sense?
You really trying to
Oh.
We start off with an x squared is bigger than an x, right? So that means we're going to have an x left over in the denominator.
I see.
Subtract the smaller variable degree from the bigger variable degree.
So you're pretty much just dividing.
Dividing it out.
Just pretty much. Okay.
Right?
See,
So another way we can think about it, say we had something like x to the third divided by x to the fifth. Remember, exponents is just saying we have something multiplied by itself that many times. So if we have x to the third, that'd be like saying x times x times x. Or if we have x to the fifth, x times x times x times x. When we divide, they cancel out, but we have those two left over. So we'd have that x squared in the denominator. Does that help clear it up?
Yeah.
Yeah, that makes sense.
So anytime you have a bigger denominator or degree in that denominator, that variable stays there. You just subtract that smaller number from it.
So,
So this is it for the homework.
This is it. So that's all of our operations of polynomials. Adding, subtracting, multiplying, and dividing.
so on number 15,